What's going on, algebros? In this problem, what I'm going to do is explain how we can find the real zeros of this polynomial function that's in somewhat of a partially factored form, along with some other things. So as you can see in the problem itself, we have a laundry list of items to go through, and we'll do exactly that. We'll go through each one of these different parts of the problem. So our polynomial function is f of x equals -8 times quantity x plus 1/4 squared times quantity x plus 4 cubed. Part A wants us to find any real zeros, and we're going to select either option A or option B. If we do have real zeros, we'll select option A. And then what we'll do is just write in or type in, if this is on my math lab, write in our real zeros. And then we'll discuss multiplicity and all that fun stuff. So for part A, what you want to do is just remind yourself of the concept here. To find the real zeros, we're trying to solve the equation f of x equals 0. So I'm going to go ahead and bring in the actual expression for f of x. So it's -8 times quantity x plus 1/4 squared times quantity x plus 4 cubed equals 0. And what I'm going to do is actually write this polynomial function in in long format. In other words, I'm going to make use of what the exponent really stands for. So here's what I mean. I'm going to write the -8 again. But I'm going to write two factors of x plus 1/4 because that's what the power of 2 indicates. And the power of 3 that's on x plus 4 means that there's 3 factors of x plus 4. So that's what the polynomial would look like in kind of its longest format there. And you notice this is all multiplication on the left-hand side, and it's supposed to give us a product of 0 on the right-hand side. So what we can do is we can sort of extend the zero product property where it says that, hey, if you've got something completely factored set equal to 0, then you can take each of those factors and set them equal to 0 individually. So that's what I'll do next. -8 will be set equal to 0, but obviously that's a false statement, so we can kind of ignore that. But we're going to have a couple of x plus 1/4 equals 0. And then we'll have 3 copies of x plus 4 equals 0. Solving for x in each of these equations, we have a pair of x equals -1/4. And then we have 3 copies of x equals -4. So there are two distinct real zeros. So for part A of this problem, we would select option A. And I'm going to write out the two distinct zeros without any of the repeats. So we'll have -4, comma, -1/4. So right underneath these two options, it says the multiplicity of the larger zero is blank, and then the multiplicity of the smaller zero is blank. Well, let's first understand that -1/4 is the larger zero. This would be further to the right on a number line than -4. And taking a look at x equals -1/4 in the algebra that we did, this solution showed up twice. So that means it has a multiplicity of 2. So I'll write mult 2. And in this space right here, the multiplicity of the larger zero is 2. -4 showed up as an answer 3 times, so this would have a multiplicity of 3. So the multiplicity of the smaller zero is 3. Moving on to part B, it wants us to decide what the graph is doing to the x-axis at these corresponding intercepts. All right, keep in mind that zeros are the same thing as x-intercepts and vice versa. Just a reminder, if a zero has even multiplicity, the graph is going to do what's called touch the x-axis, and if it's odd multiplicity, the graph is going to cross the x-axis at the x-intercept. So the multiplicity of the larger zero is 2, which 2 is an even number. So what that would mean is that the graph of f is going to touch the x-axis at the larger x-intercept. The multiplicity of the smaller zero is 3, and 3 is an odd number. So what that means is the graph of f is going to cross the x-axis at the smaller x-intercept. So I'll say the graph of f crosses the x-axis at the smaller intercept. For part C, they want us to determine the maximum number of turning points on the graph. And this kind of goes in line with part D, where it asks us to write out what power function that the graph of f represents for large values of x. So I'm actually going to go back up to the partially factored form of the polynomial function. And here's a little trick. So if we were to FOIL out x plus 1/4 quantity squared, the largest power of x that we would get from there is x squared. If we were to FOIL out x plus 4 quantity cubed, the largest power of x that we would get out of that is x cubed. So tying these two powers of x along with -8, what that means is if we were to multiply everything all out, this polynomial function f of x would have a leading term of -8x to the 5th, and I'm getting the 5 by doing just the basic rule of exponents, where if you multiply two expressions with the same base, you simply add the powers. But of course, there would be a whole bunch of other stuff that comes up after that as well. But in terms of end behavior and turning points, this is really the key term of it all. In fact, this polynomial function would have a degree of 5. So what that means is that the number of turning points, I'll say number TPs, is going to be 4, and that would be the max number of turning points, by the way. And the reason why we know it's 4 is because it tells us in the section 5.1 that the maximum number of turning points is always n minus 1, where n is the degree of the polynomial function. So for part C, the maximum number of turning points on the graph is going to be 4. It's always 1 less than the degree of the polynomial function. And then for part D, that leading term that we discovered up here, -8x to the 5th, that's what we can type in for the power function. So for large values of x, the polynomial function will resemble the graph of just its leading term. And there we have it. And I'm looking underneath this answer spot for y equals -x to the 5th. So it says 1, we have the option between crosses or touches, and 2, we have the same options. And I believe that this is probably just a copy and paste error on my end. I believe this goes for part B. So for part B, you would select the touches option for number 1, and then also for part B, you would select crosses for the answer choices to part 2 of that. Alright, so hopefully I didn't confuse you with that. I didn't notice I had the answer choices underneath everything. But of course, you know, if there's something I can clarify, feel free to let me know. Otherwise, we are done with this problem. Thanks again for watching. I'll see you in the next video.